So, if you've been working through the series, you'll be surprised to know that today's installment is of even lower production quality than everything you've seen so far. What I have done now is I've gotten to the end of the material for the semester that I intended to cover, and so now I'm going back and doing episodes like this for previous classes so that we have the whole thing continuous. So, today we're going back to the beginning. Today is a recorded Zoom meeting of the one and only Zoom meeting we did for the Intro to R class 1 week after spring break when we couldn't return to our classes in person, and instructors were left to just figure out how to do it all remotely. And after that, I shifted to this YouTube format, and I think you'll see why. But rather than redo that material for that lesson, I decided to just edit the original Zoom meeting down to a shorter version, take out some of the stupid, awkward moments. Plenty remain. Don't worry about that. And just leave it there as kind of a time capsule for how things are in the United States in 2020 with the COVID-19 pandemic and how life was. So here you are. Just if you live through this period, here's another happy trip down memory lane with Zoom meetings. And if you are unfamiliar with the pandemic and the quarantine and the great isolation, count yourself lucky.
Get started so we don't have to spend a ton of time on this, but the main points that I want to cover today are handling some stuff with, well, we're going to create a timestamp and go over some of the ways that R handles time class, time date classes. And we're going to do it with count data. So when we talked about distributions, we talked about continuous distributions, and we were fitting what are called PDFs, probability distribution functions. We talked about how when you have a Gaussian curve or even one of those gamma curves, that the area under that should integrate to 1 for that, and that's fitting over continuous data. And we talked about the difference between continuous data and discrete data, and that when you have discrete data, you can't have a value that's between those values. So it's impossible to have that that integration like that because you don't have the continuous, it's not infinite between points. So for those, for count data, well, so count data are a very common type of discrete data. And what we fit to those are called probability mass functions, PMFs, and we're not going to do that today. Anyway, we're not going to talk much about continuous distributions, but we are going to do some stuff here that is more on the chuggy side of how you handle count data and how we graph them, and then we'll do the stats for this next week, I believe. So everything we need today is in the tidyverse. The data that we'll be using are some stuff that I got sucked into. So this is when people find out that you can do R, you might get sucked into doing stuff, and that's kind of cool. With this is a guy I went to college with. He was on my cross country team. His PhD was on what alcohol policies in different towns and stadia at universities, how that affects whether people get picked up for alcohol in the neighborhoods around the stadia and at really big SEC and ACC stadia and stuff. And so as he's gone out, he went and got these data that are all the crimes within like half a mile, I think, of the 2 main sports venues in Cleveland. So that's the Progressive Field where the baseball team Indians play, right? And then then there's a complex that has the basketball stadium and hockey. So there's these 2 discrete, spatially discrete venues in Cleveland, and you got all these crime data that happened within half a mile radius of these places and wanted to see if there was an effect of it being a game day, if it changed the amount of crime, if it changed the type of crime, and if it changed when in the day those crimes occurred. And the idea is that you can the local police could better plan for what sort of enforcement they need to do and when, if they have an idea of what these crime patterns are. So he was having a hard time getting his paper through reviewers. They're asking him for a whole bunch of stuff. He was trying to do it in SAS. He came to me, asked me if I wanted to help him out. And I agreed because at this point, I've never used a lot of count data yet. And so it was a really good opportunity for me to try to fit some of these models. And so what I'm doing here is sharing those data with you. It's the example data that we have, and we can look at it. So you see, this is from the Cleveland. This is pretty much the raw data that comes from the Cleveland Police Department. You can see the address to where the police responded, the date, the time, and there's 3 different levels of charges. There's what was reported. You can see that has 96 levels. That's so there's a lot of different types of crimes you can do. There's more than I really even knew. Not that it's a bucket list or anything, but so you can look at that. You can see all these different crimes. Then we went and kind of just put them into different, some general categories. So, so this is, looks like there's about 19 or 20 of these. And so you can see you got aggravated murder, assault, domestic violence, kidnapping, weapon. I don't know if that's being a weapon or having a weapon, but anyway, you can see what all these different types of charges are. So you can see here on the, we're going to use, we'll go back to GeoMBar, and again, when you're using a stat like count, it's doing, when you're using a stat in a geom like that, it's doing calculations for you, and it's assumed that the result of that calculation is going to be on the y-axis, so we don't need to give it a y. We just define x, and it's just going to count up general charge for us, so that stat equals count there. We could count it differently. We could count it somewhere and have y equal count, and then stat would be identity. But since we're just looking at it, this will do it for us. So take a look at that. We've made bar graphs before on the first day when we were looking at things. You can see here that, okay, that's a potentially kind of a useful graph. We can see that there's some crimes that are infrequent. Some crimes are quite frequent. There's a big train smash of words along the x-axis, so we're going to try to clean this up. So the first thing we can do is reorder that by putting this reorder function, wrapping that around our x. Now we've used all this before. You might not remember it, but we're using this early on, and so now we've at least changed the order of that where it's descending. We can. And you can see here in each of these, I'm updating that charges.gg. I'm just adding ththese things to that ggplot object. And it's just cleaning up the axes a little bit. Here's some tricks. This is just a good one to put in your back pocket for things that you can do when you run into things like axes like this, where they're all smashed together. You know, if these were just 1, 2, 3, 4, 5, if these were days of the week, you could just do, you know, MTUW, whatever, but we have some longer things, and so we can adjust the theme. You can see this in the x on the axis text. .x is going to specify, it's going to map to the x-axis. It's a text element. We're going to change the angle of it, and then we're going to change the horizontal justification so that it's and you'll see, and you should go home and you're already home. Stay home, and play around with these, and you can see how they change. And we just run those again, and you can see that we've the HJust1 just means that we've put the end of the word at the tick mark, and you can see the angle tips it down. So now we can read every single one of those, and we have that in a descending order. So that graph, I think, just got a lot more legible and useful than when we started. Now, looking forward, we can just see that there's a lot of these. It's it's kind of like scree plot sort of stuff. Where do we, there's a lot of charges, but we don't have them numbered. But all of these are less than 25, and looking at the max is approaching 100. And so any of these that's down below, a certain percentage for sure, you kind of come up with your own rule. But a lot of these other things we could probably just write off as others. And now, granted, I mean, one of those is endangering children. So I'm not saying that this is just a crime that we're just going to put into the other, because and gross sexual imposition, these are serious crimes. That they're really, I mean, rape, kidnapping, rioting. But as far as their frequency, and we're just going to put those in this other category. So for that, those are going to be these are the crimes then that we are going to be analyzing, because there's just enough of these. And something like minor alcohol, well, that's fairly low, but that might be one that we're particularly interested in. That might be one that we have a hypothesis that's going to see a difference with having a professional sport going on, a professional sporting event that day. Maybe we have more minors in possession of alcohol. So even though that's low, that may be one that we keep discrete. So that's one where, how we bin these things really comes down to your research questions. Obviously, if we want to see how these go by game day, we want to calculate by that. You can see we're just going to group by charge type, and game day using the dplyr pipes, pretty straightforward for the skills that we've already used. So you can go in there and you can see that we have game day for us is just listed as 0 or 1. It either is or it isn't. And you can see the number of charges there. Down charge type, each one of those is of course repeated because, well, except for endangering children. So this is one that's interesting. And as we suspected, whether this is going to come out and be something that is statistically meaningful or not is a whole nother question. But you can see, like, we just didn't have any instances of endangering children on days where there wasn't a game. And we had 5 of these, and however, I think it was maybe a year or 2 years. It spans multiple seasons. It spans all the seasons of all these different sports. And you can see minor in possession of alcohol. We didn't have any instances of that, of people being cited in the neighborhoods around those stadia on days that there wasn't a game, and there was 4 instances of that in there. So that's already we're starting to see some interesting patterns, I think, in terms of what the type of crime are encountered around these stadia, depending on whether there's a game going on or whatever. Run another ggplot there and just put that in as an aesthetic and give us and you can see that in there we've changed the labels. So the 0 is no and yes, so we know what one's in. So yeah, we definitely see a different skewness in proportions. So if we look at that, just all the time there's violent crime. There's a fair amount of it, but a major contributor to that is whether there's a game or not. And another one that stands out is resisting arrest. Looks like there's only 1, 2. If you look at the data, there's 2 instances of that on days where there wasn't a game, and there are 23 instances of that when there are days that there are a game. So, okay, I'm going to pull out just these 3 levels now. Look at those and we can see those. I'm going to show you how this is just some text manipulation. I don't like that these are all in uppercase. This is just how it came back from the cops, though. So we're going to use mutate here. There's a nice little text manipulator function called toLower. It just means it's going to make all the characters in that lowercase. So just some formatting tools that you get. And you can see that we, I don't know if it was the toLower or if it was the mutate, but it's dplyr tends to make things, if things are factors, if things tend to change, it's a factor going to a character. And in this case, that's what's happened. This has gone to a character. I don't know that, it's just something to be conscious of. It's not going to change anything for us. But if you have something later in your script that depends on a factor, reordering factor levels or something, you need to be concerned about, or pay attention, cognizant of when you've changed that. So there's the three that we want to focus on. And lowercase, we've still gone and done the angle on the words, although in this case we might not need to. But so we're learning some formatting tricks around here as we get different types of data. When there's, for a lot of what we do, we can say yes or no for a lot of our biological data because they're just like levels of a treatment or numbers or numerical. Here we, we're using more data of more of a social nature, and so we want to carry that information, and we need to pay a little more attention to how we're formatting. Now we're going to work on a time series. What we're going to do here is actually make a timestamp, and we're going to use an R class that is specifically for timestamps, or what the R calls date time objects. POSIX is a general class of objects, and there's a couple types. Tidyverse, really, and ggplot then will only use the POSIX CT. If you try one of the other ones like LT or whatever, it'll barf at you and it'll say, hey, we can only use CT. So I'm not going to get into what the differences on that are. I'm going to show you this. Since we have these as functions, very similar to changing anything. We're changing a class. It's the same as going from integer to numeric to character to factor. This is just another class for us. So the cops here have given us different columns for the date. So that's the day on which this occurred, and the time. Now, what we can do if we were making a data logger, we might just put those together and we might just have a timestamp column come out. But here we have to make a timestamp column. And we're going to do that using the tidyverse function unite. We've used this before, where we can bring two columns together and separate them here. We're going to use a space. This can be whatever you want, but we get to decide what we want our timestamp column to look like. So there, now we've smashed the date column and the time column, and we've put them in together. But at this point, these are just characters. They're unique, but we're not able to access any information in there. And for a lot of what you do, this might be fine. But the timestamp objects, these POSIX objects, are extremely powerful because they store all of that time date information in there and allow you to access it. And you can even start adjusting your plot. If you're in ggplot, you can adjust your axis to read it by timestamp. So if you just want the months shown, if you want it every 2 weeks, if you want it every 4 weeks, but you want it in weeks, not months, you can do all that formatting with the plot. You don't need to change or have a whole bunch of different columns in your original data, or go back to Excel and change up all your columns to be the format that you want and bring it back. You can just store it as a single column, as a timestamp, and then do the formatting later. But they're tricky. The first thing to do is you have to make it into this class. So that's the as.dot function. You can see it there. We have timestamp is going to be changed. We're going to mutate timestamp into a POSIX CT object. You can see we're applying that to timestamp. And the key here is we have to tell it the format that it is in currently, not the format that we want. And you can see in here some weird characters, so it has to be included in the quote marks, and each little subset of information needs to be preceded by a percentage sign. I don't know why, but that's just the way it is. And lowercase m means something different than uppercase m. It's all in the help files. They have a big long thing that'll tell you all about it. So it's really helpful. You just look at what it is. So a lowercase a is an abbreviated weekday name. A uppercase A is the full weekday name. So you kind of be like, why do we need that to be so specific? But man, you can change your timestamp into whatever you want using all of these different codes that represent the format. Look at that. That's a whole crazy amount of codes that that you can go in and format stuff with. So you can see what I have here. If you look, what we have, our timestamp is the month, the day, the year separated by slashes, and it's the full year. It's not just like 13 or 09. It's 2009, 2013. So that's uppercase Y, lowercase m slash lowercase d slash uppercase Y space. That's the space that we put there in the SEP. So that's the space, and then we have hours and minutes. And it's uppercase because that's what we have, I think, because it's in 24-hour time. You can see we have 13:30, 13 here. Anyway, so you can play with all that. If we had seconds, you would put, but it would depend on if your second was by a period. You might put a period, parenthesis, S, whatever. But what this isn't where you want it to go. This format is the current format of timestamp. Whenever, I don't know if I've ever made one of these run well on the first try. They're kind of fickle, but the binding thing is to remember you have to make this look exactly like it looks in the column. Otherwise, it'll just return NAs because it's like, that's not a year, buddy, and it won't give it to you. So, yeah, so you can do that. Then, oh, look at that. So it's changed the format of it considerably. Now it goes year, month, day. Again, it's changed it into its default output format, but it needed to know what our input format was. You can see that it's smart, but it's not too smart. Anybody knows anything about Ohio? What did it add? What did it add to our timestamp? It not only changed the format, but it added two things.
Didn't it label it as Central Time?
Yeah, okay, so it added the time zone, right? But it called it Central Time. What do you think of that?
Ohio is not.
Ohio's Eastern, isn't it? Yeah. Why do you think it used Central Time?
Because that's where we are, like that's what our computers are set to.
Yeah, so if you read in the if you read here in the help files, it talks about what they call the local, or the locale that you ran it in. Locale specific conversions to and from character strings are used where appropriate and available. So you can change this. You can set your locale. There's also at the bottom here, Z, output only, time zone abbreviation is a character string. So you can change it. And then, so if you're going in with a lowercase z, it'd be offset from UTC, so you can, sorry, keep it in reference to Greenwich Mean Time. If you really had stuff from different time zones and this really mattered, you'd probably convert everything to UTC, Universal Time Code, and then have it be offset from that. It's added a time zone, which is kind of smart, but it's also kind of dumb because it didn't use the right time zone. But hey, it doesn't know where these are from. What's kind of smart about it, though, in the time zone, somebody see something that was smart about the time zone? It's consistently Central Time, but what's also variable?
Savings time, daylight savings time.
Yep. It knows because of the dates. It can read the dates, and it knows which side of daylight or standard time those are on. For our purposes, this is not going to be something we need to worry about, but with a timestamp in this format, it's going to carry all of this information. Look to the class for this. It's generally POSIX-T for time. I don't know what the POSIX stands for. And then you can see that it's CT is the specific class, and that's what we want. Okay. For our purposes in knowing, going back to the research question for this paper, we were interested in the time of the day, and we didn't really care what the specific time of the day was, so we decided to bin everything by hours. It's just a better way to model them, to have them in bins, because there's very rarely you're going to have things at 1 minute and then I have a lot of crime in the same minute, in minutes that are proximal. It's just kind of hard to manage. So we're going to make these into hours, and this is one of the great things about this having a timestamp is now we're going to create a column. So we see mutate here. Mutate, we're going to create hour. Hour's not a column. We're going to create an hour column, and we're going to reformat. So here you can see up here, format was an argument. Here, format is a function. And it's up here because it gets used as, it gets internalized as a function. So this is the argument that goes into the format function that when it makes it this date class, it needs to know what format is, but it's using this function inside. And so now we're going to reformat that timestamp just as the hour. So everything is going to be stripped away from it, except for its hour. You can see that it's got the quotes around it. So these are characters. We do want these are numeric values. We want the hour to be sequential through the day. So we'll convert those to numeric. Now, one of the issues is with these data, and this is something like, okay, I'm showing you this. This isn't a core skill or tool that you're going to need, but it's an example of how you can manipulate things to just work so much easier for you. If we're talking about what time of day crimes are committed in, especially if it's a game day, we want to make sure that 2 a.m. of a night of a game is a game day. But if it's after midnight and there was no game the next day, that 2 a.m. is going to be registered as not a game day, even though people might be out partying after a night game after midnight. So we need to make sure that even when things roll over midnight on the next day, that we still have them attributed to game day. So you can see what we're doing. We have our hour column. We've made it numeric, and we're just doing a simple lesson. So if it's before 8 o'clock in the morning, so I'm going to have all this. Everything is going to start at 8 o'clock in the morning. If the time is already before 8, I'm going to make it be the next day. And then if it's not, it's just going to be the day that it is. So everything gets shifted up by 8 hours if it started before the end of the day. So the hours function is a nice way to, if you needed to shift these back, now that you've done this conversion, hours, you could just do hour minus 2, and it'll work on a 12 or 24 hour period and not just subtract the numbers. That's what the hour function is nice for. You can just do hour minus 2. And if the hour is a 2, like 2 a.m., and you take off 4, it'll put it to 10. 22, not -2. That should be pretty clear how that's very, very useful when you're messing with time stuff and you need to add or subtract time. You're not working on a whole continuous gradient of numbers, you're working on a clock. Now we have these charges, and we've shifted the days a little bit. So now we want to know how many charges there are per hour. We're going to group them by whether it's a game day or not, yes or no, the type of the charge, and then on this adjusted hour. Apply this earlier thing that we did to make sure that the game, now this is, we plotted this before this. If it was a game day, it's stored as 0 or 1. Now we're going to make it be no or yes. Just going to straight up change that column. And in case there's anything in there with an NA, I'm not really sure why that would be. It might just be that for some of the charges, the hours weren't given by the cops. So this is just, we're just going to clean that up. And now we're going to make a bar graph because of this step that we just did on like line 35 here, where we actually did the summarization of the number of charges. Now we have that as a data column, and we have to define that as a Y variable, and then that stat identity. Before when we made bar graphs, we didn't use the Y, and we call it stat count. And GeoMBar just knew that the Y-axis should be the stat. So it's counting, it was calculating. Stat identity means don't do a calculation, don't do a stat, just take it as it is, the identity of that value. So there we are. We have our 3 charge types that we were interested in and time of the day. You can see it starts at 8 o'clock. We have it binned by, looks like it automatically binned to give us the day in 5-hour increments. And of course, this is a 24-hour time, and it's because we added the 8 hours, it's not really reading that as it's thinking that we're counting up from 8, which we kind of are. It's sequential from 8 a.m., but obviously 25 o'clock is 1 a.m. the next day. But you can see there's a fair amount of charges that occurred after midnight, and you can see that we definitely want to have taken account of having those on the same day. So we have that. If you look at the next bit, I'm manipulating the x-axis scale. It's reading that it goes from 8 to 28. I want it to go from 8 to 22. We're gonna shorten that down, and we put some increments in there, and we're going to facet it at this point by game day and charge type, so we can see the allocation. And so the x-axis is still going to be the hour of the day, but we're going to get to see our facets by the charge type and the game day. Excuse me. And you can see here that we're applying this labeler argument. It just means that because we don't want our columns to just say no or yes. Now it's going to say game day. So we'll just go ahead and run that and take a peek at that. You can see on our time of day, it goes from 8, and then it restarts at midnight is 0 and goes 2 to 4 in the morning. So we have a 24-hour period that it starts it from 8 and goes into the next morning. You can see 3 charge types, and you can see that there is a change. There's a change in all 3 things that we expected. There is a change in the overall amount of crime. Bars are higher on game days. There's a change in the type of crime, and there's a change in the distribution during the day of the crime. So you can see violent crimes aren't typically occurring. Like, you don't usually get violent crimes over lunch, apparently, in Cleveland. Well, no, that's about the end of the evening commute there. That's between 4 and 6. But that's when we get a lot of, so the afternoon, daytime, afternoon, and we have a lot of those occurring earlier in the day. And same here. So we have resisting arrest occurring around noon. There's just not a lot of those in these neighborhoods. There's a lot of them, and they start early and they go late. And property crimes are more frequent, but they seem to change a lot less. So we've crunched these data, and you can go to the Cleveland Police Department and you can say, like, look, you're going to have different types of crimes, and they're going to come out earlier. So on days that one of these venues has a match or a game, you probably want some more cops out there earlier in the day than you might have thought before. And this is the sort of crimes that we can expect. I just hope you see that there's some really useful stuff. There's a lot of stuff in here that I think a lot of you would probably expect to have to go back into Excel to do. And not so long ago, I would have done that as well. And so changing your columns, but just bring the data into R, and we can do a lot of that stuff once we get in here without changing the underlying data, and really clean stuff up for people. So because the last time I did this class, I had just gotten these data. This paper has been published since then, and it wasn't even published at the time I did the class last. And I don't have an exercise, a homework exercise for it. As you can kind of see, the nature of the data, I can go and get count data, but to make sure that you can get somewhere with it and not have to do a bunch of other ridiculous stuff, I do have another data set that I've started to clean up and simplify so that we can make a similar, just count by group by time homework assignment. It's not ready yet, but I'll get that posted sometime tomorrow. And while we're talking about homework, I'm going to get caught up on grading this week. And I'm going to continue to have things set with a due date on Saturday mornings, just so you have a chance to get them in and get feedback on them in a timely manner. But I'm not going to pay any attention to what time things come in. So if you can't get it in by that Saturday morning, have zero worry about it. Get it in before the end of the semester to get points for it. It's just that if you have it in by the due date, you can expect to have feedback and comments, if necessary, sooner than later. Otherwise, if you get it in late, you're just going to have to wait till I go back and go through the assignments again. Although at that point, you'll be first on the next round, because I just grade in order of submission. So any questions on that? Hopefully that makes things just a little easier, something you don't have to worry about, especially if the assignment doesn't get posted until tomorrow. All right, we all good? Okay, well, so I don't know how to share it, but this has been recorded. We probably could have been doing this the whole time, and I wouldn't need to actually do this class next time. It's on the schedule. But if you did miss anything, all right. Well, stay safe, stay alone, wash your hands.
So I think you can see why we went to the YouTube business. That wasn't the worst attempt at doing the teaching via Zoom, and I think I did get better at it for my other classes later, but what you saw there was heavily edited with a lot of awkwardness and long pauses and trying to fix things. You hear that? That's the curfew. It's 10 p.m. in Sydney, Montana in the year 2020, and we have a fire alarm telling us that there's a virus outside and it's time for us to go to bed. So with that, I hope that you're healthy, doing well, washing your hands, and also enjoying learning R while you're inside. We'll talk to you later.
Any questions? If anybody has a question, does anybody have any questions or thoughts? You can wave your hand whenever you need going forward. I'm sorry, this doesn't even use that. Did anybody not get this? Everybody's with me? Okay, good. Anybody knows anything about Ohio? Can anybody chip in and say what's not smart about this? Anybody have any ideas? Any questions at this point? Okay. Hey, Rachel, are you going to bed? So, are there any questions or thoughts on that? Are we out there? It's don't need to have much to share about it. It's all pretty straightforward. I've been doing more talking today than I have in like 3 weeks. So